Hey everyone, thanks for joining us for the next episode of our Python and AI series, Function Calling and Structured Outputs. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our speaker for today. Pamela, thanks so much for joining us.
Hello, everyone. Very excited to be here. As always, welcome to our Python AI series. For those of you new to the series, this is a 6-part series where we're covering all the fundamentals of using generative AI in Python. We are very near the end of our series, but you can catch up with any of the previous recordings by watching them on YouTube and also checking out the slides. You can download them and use them for whatever you want. And you can register to make sure that you're signed up for the final event happening on Thursday about quality and safety. We also have this series in Spanish, and my colleague Gwyn is in the chat, and she can link you to the Spanish series if you are a Spanish speaker. So today we're going to be talking about function calling and structured outputs. Those are the two main ways that we can get structured responses from LLMs, and they're really, really useful. They're actually used very commonly when building agents, but they're also used for all sorts of automation and just to get more structure out of LLMs than just a conversational response. So this is a really good tool for your toolbox if it's not something you're using already. If you haven't met me before, I'm Pamela Fox. I'm a Python cloud advocate. So that means my job is to help Python developers be successful with Microsoft and Azure technologies. So for today's session, you can totally follow along with all the examples for free. And the way to do that is to visit this repo here. I'm going to show you the process. Why did you go there? The repo. Okay. Oh, PowerPoint. All right. The full URL, which is shared in the chat, is this one. Okay. So I go to the repo and then I click on code and I see this big tab for code spaces and I click create code space on main. So what this does is opens a code space in the browser. And so it's going to look like VS Code, but it's going to be inside the browser and it's going to open with the project inside the environment, and the environment will already have Python and already have all the requirements that we need for today's examples. And that one actually loaded really quick, which is great. So this is what it looks like. So if you want to follow along, go ahead and open this repo in a code space and you'll be able to run the same examples that I do. All right. So let's just do a quick review of how we call LLMs, just so that we can compare that with how we use function calling, right? So when we call the chat completions API, this is using the OpenAI package, but it looks similar with other packages. So we say, create a chat completion. Here's the model we want to use. Here's the temperature. And here is our list of messages, right? We often start with a system message in order to convey the overall tone and instructions, right? So this one's like, okay, you make lots of cat references and use emojis. And then we give the user message, which is what we want the response to, right? So in this case, it's write a joke about a hungry cat. So here's like that with a full example, write a joke about a hungry cat. All right. And I can run that. And that's going off to the model and getting back a response. Now, when you open this in GitHub code spaces, it's going to default to using GitHub models. So GitHub models are free models that anyone can use who has a GitHub account. let's see. All right, so there's my, let me do this in GitHub code spaces, actually. I've got it open locally as well, but let me also do it here. Okay, chat.py. All my extensions opening. All right, so this is GitHub models. And it's a bunch of free models that you can use. And the reason they're able to be free is because they are rate limited. So there's only so many that you can use in a day. Like you can only make so many requests in a day. And the rate limits are documented in the GitHub documentation. But it's really nice for getting started. You should be able to, go through all the examples today and not run into any limits. And here we go. And this is a response from a GitHub model. And we got a haiku here. Let's change this to a joke. See if it can write a funny joke. Can you do it? And this model is GPT-4o that it's going out to. But we could switch in any of the models if we want to try out a different model. Let's pause for a moment and craft the perfect joke. Why did the hungry cat sit next to the fishing boat? Because it heard it was the perfect place to catch a tuna break. I don't know. I don't think that was a joke. If it was, I didn't get it. I think we'd have to have it generate a lot of jokes and then pick one. But you could try that with, you could try this with other models as well, right? So we could try that with, let's see, is it 5.4? You do have to type it correctly according to the model catalog. Okay. All right. Why did the hungry cat bring a ruler to the tuna shop? Because it heard they were offering tuna scales on sale. Okay. They're funny in how bad they are. All right. Anyway, so that's our basic chat completion. So now let's talk about how we could get more structured responses, right? Now, one thing that people did at the beginning is they'd write something like, output JSON that describes a cat name, age, and breed. Okay. So that's what we did in the beginning when we wanted some sort of structure to our response is we usually would tell it to output the JSON and, and it actually did fairly, it can do fairly well with this. The problem is it didn't it put here, it put cat inside an inner object and it added on a description, which I didn't want it to do. Right. So, it didn't really do it didn't follow exactly the JSON schema that I wanted, right? So this is how things started off in terms of getting structured responses. But since then, we've come up with approaches that the models are actually trained to do and that we have systems in place to make sure that we have a way to describe exactly what we want and then a way to validate that it is what we want. So that's what we're going to be seeing today. So let's start with function calling. Okay, so we're going to start with the basic function calling flow and walking through that. So first thing, as a developer in the code, I tell the LLM, hey, here are the possible functions you can call. And I give it a bunch of function definitions. And then I send that to the LLM and the LLM says, oh, okay, all right, well, based off the content and the possible functions, here's a suggested function name and the suggested arguments. And then it's up to us as the developer if we want to then actually call a function in our code. So a big point I want to make is that the LLMs don't actually call the functions. All they do is suggest what functions we should call. So let's see, what that looks like in code, right? So the first thing we have to do is describe the function that it can call. So this case, we're describing using this JSON schema. So we say, okay, you can call this function, which has the name lookup weather, and here's the description. I can look up weather for a given city name or zip code, and it takes these parameters. It takes a string, which is city name, and it takes a zip code, which is also a string. So now we've described in a very structured way, here's a function you could call. And then we ask the LLM, we give the LLM a conversation like usual. And we tell it hey, if you want, you can use these tools here. And the tools are functions. And it's just this function here. So the LLM can decide that maybe the best response is to suggest a function call. So let's actually just open up this example. Here we go. Okay, so function calling, right? So here's This is our function definition, right? And then here's our conversation. I say, okay, what's the weather like in Berkeley? And then I'm going to run this and see what it responds with. And so now this time, okay, so we got a response and it says, it suggested that we should call lookup weather with the city name Berkeley. Oh, and this is actually running locally on Olama. I keep switching between local and GitHub models. So even with Olama, we can do this, which is pretty fun. Let me also try this in with GitHub models in the code space. So here we go. All right, so we're gonna say run this one. All right, and so this is from GPT-4o on GitHub, and it says, okay, the name of the function you should look up is that you should call is lookup weather, and here are the arguments, and it gives us the arguments in a dict. So this is what the LLM gives back. It's just telling us the name and telling us the arguments, and then it's up to us to decide what we want to do with that information, right? We might use it to call a function. We could also use it to do something, something different. I see a question like, what temperature level should you use? Yeah, it's a good question. I don't know that I've seen studies about that. You can see I left temperature off here, so I think that it's doing the default, which is really low. If we did do like 1.0, which is really high, let's see. I would imagine it would still do good for this question. But yeah, generally with functions, I would say you want to do a pretty low temperature. So 0 or near 0 is what I would recommend. As always, you can experiment with that, but we do want to we want a high degree of accuracy. And when you want high degrees of accuracy and low degrees of creativity, then you typically want very low temperatures. So we can also, ask, what's the weather like in that city with the big pointy tower? Let's see how it does with that one. Paris, that's what I was thinking of too. So that's the fun thing about LLMs is that, users can give us really unstructured data and LLMs can turn it into very structured data, right? So here we see like, okay, they want weather and the city name is Paris, right? Okay, so let's go to the next step here, right? So we get back the response. Now, one thing to note is that you're not guaranteed to always get back the tool call in this case. So you often want to check to make sure like, oh, does that, does the tool call definitely exist? Okay, if it does, then we'll pull it out. Otherwise, you can, print out the response. I think that interesting. It's okay. Yeah, that's correct. All right. All right, so there we go. So that's getting back the response. All right, so now let's look at how we would actually call a function based off the response, right? So let's say we actually have a function here. So I've made a function that has the same signature, right? Where it's called lookup weather, it takes a city name, it takes a zip code. And then I, call the LLM and get back the function name and arguments. And what I do here is I say, if function name equals lookup weathers, then call lookup weather. And this star here is an operator we can use in Python to say, hey, take the dictionary and unpack it into arguments. So it's a nice way of being able to programmatically construct arguments for a function. Because you can put them all in a dictionary and then you can just star that dictionary and then these will get passed in. So like really what this is doing is actually doing, city name. Yeah, it's doing what it says there, right? This is what it's passing in. So that way it'll actually call the function up here and do something. Now, the interesting thing is like the function name locally doesn't need to match the function name from the LLM. I did that, for nice clean code. But it could be, it could be completely different, right? Because it's up to us what we do with that information. So that's just the point I'm going to make, several times is that we are the ones calling the functions. The LLM is just saying, hey, here's what I think you should call based on what tools you said you had available. And then it's up to us to take that and convert that into something useful we can do in our code, right? So that worked. It says it's looking up the weather for Berkeley, right? And then at that point, we'd probably want to call like a weather API and get back actual weather information. Okay. So, yeah. So I see the next question is like, okay, what about passing this back to the LLM, right? And yeah, we should do that as well. All right. So let's talk about, so that was our basic flow. Now let's extend that flow a little bit farther, right? So the developer is going to call we call the function our code, we got back some response, right? Then if we want, what we can do is actually add that response as a tool call response to the LLM, and then send that to the LLM, and the LLM can give a response based off the whole conversation, which includes the user message and includes any tool call responses. So let's see how we would do that. Oh, interesting. So somehow, all right, I was wondering about this. I think somehow I lost this example in the history, so I'll add it to it afterwards. But it's okay. We can just take it and add it here. All right. So I think this example isn't in the repo for some reason. We somehow lost it, but I'll add it in here. How did I? Gosh. Okay. All right. So it's okay. We'll reconstruct this. All right. So let's say we're going to have messages. Yeah. So what we're going to do is store our messages in a list. And, we'll start off with this list, right? So here we have, is it sunny? Okay. Here's the question, the tools you can use. All right. And, if this is good, we can look up weather. All right. And okay. So what we're going to do is when we get back this response, we add that response to messages. So we've added the tool call response to the messages. Then we look up the weather. Then we add the result of that tool call to the messages as well. So we're adding two messages for these tool calls. One that has the suggestion of what tool to call, and the other that has the response from that tool call, right? And you see they have to actually reference each other. So see here it says role tool call ID equals tool call.id. All right. So we have that's from the response. It has an ID. And then the content is a stringified, result from the function. So if we look at this function, I'm going to actually get this to return back. Yeah, I'll get it to return back a JSON, since that's more likely what it would do. Okay, so it's going to return back a JSON and then stringify that JSON, add it to the messages. And then we can send the new updated list of messages to that model. Let me do model name here. Okay. And then we have the tools. All right. Let's see. Oh, and I just did that all locally. Let's try that in here. All right. Let's see. Let's see if that'll work. Might have to make some changes. All right, and there we go. It says, let me go ahead and print all those messages so you can see what we sent in the end. Print messages, okay. Okay. Let me print those nicer because that's really hard to read. Do I have Rich in here? Did we bring Rich into here? Rich is so nice. Yeah, I think we do have Rich. Okay. Rich is just a nicer way of printing things out. There we go. All right. Beautiful. Okay. So what you can see here, it kind of mixed and matched. It's mixing and matching the JSON with the OpenAI objects here. But we've got the system message, the user message, the message that has the tool call suggestion, which is the function with the name and the arguments. And then we have the message that has the actual response. And we sent that all to the LLM. So when the user asked, is it sunny in Berkeley? We went out and used the LLM to figure out what function we should call. We called it, we got back the response, sent that all to LLM, and then we get this nice response that is both accurate and is answering the question in a friendly way, right? So yes, it's currently sunny with a temperature of 75 degrees Fahrenheit. Okay. All right, so that's our extended flow. And that would be the most standard way of using function calling. The interesting thing is I actually have never used it that way. I've always like taken the function results and just used it to do whatever I wanted. But this is the, kind of how it was built to be used. So you definitely want to use this flow when you're getting started and see if it works for you. Now, in all those examples, we were only choosing a single function, but you can also have it choose from multiple functions, right? Because, your users might be asking many things and you might have multiple, tools that they could use, and you want to be able to have the LM pick from amongst these multiple functions, right? So we could have a few different functions like get weather and get movies, and these are function definitions here. And then we can tell it how it should choose, right? So if we say tool choice is auto, then it can choose to say, suggest 0 functions, 1 function, or even multiple functions. If it's required, then it has to call at least one of those functions. You can also tell it specifically which of the functions to call. Or you can say none, don't call any. I don't know why you would do either specific or none, because that doesn't seem that useful to me. So I either am doing auto or required. So let's look at that example. That's function calling multiple.py. All right. So here I've got the lookup weather function, and then I also have lookup movies. All right. And then I have this question: is it rainy enough in Sydney to watch movies, and which ones are on? Right. So the user has a lot of questions. Luckily, we've got multiple functions that can help answer those questions, right? So let's go ahead and run this. Okay. And so we get suggested to look up weather on Sydney, and then look up movies for Sydney, right? So these functions are actually pretty similar. So we didn't get to see how much different they could be, but you can have very different functions, right? And it can suggest all the right arguments for all of them, and the arguments could be very, very different, right? Like in this case, like let's say if look up movies, for some reason I had a completely different, maybe for movies, you can only say the like city, and you can't say zip code. All right, so we'll just say city, right? So this time it should hopefully suggest city name and then city for the second one, right? So you can have them be very different. I saw a question like, oh, is this different per LLM? So yeah, it's a good question. Like actually, if we go here where I'm running this locally, and I go to this, the multiple example. So here I'm using Ollama with Llama 3.18b, right? So now I'm going to call this function calling multiple and see how it does with this request here. Dun, dun, dun. And this is slower because it's actually calling on my Mac. Okay. Oh, interesting. All right. A little bit of a maybe hallucination there. So it came back with 3 different calls. A lookup weathers to Sydney, a lookup movies to Sydney, lookup weather to Sydney, and then a lookup movies with an empty city name. So that's interesting. So generally, I mean, this is with a much smaller model. And, that's part of why we definitely can see hallucination much more often with smaller models. And in that case, when I've been trying to use smaller models, what I usually do is provide examples, few shot examples, and that definitely helps a lot, especially with 3.1 latest. I've worked with that one in function calling quite a bit, and it really helps to give it some few shot examples to see exactly what it should be doing. So in that case, it hallucinated. We could try a different model on GitHub. I think that there's one that supports, I think is it O3 Mini supports function calling. Let's find out. So we're going to call O3 mini. And this time O3 mini did come back with look up weather in Sydney, but it didn't suggest look up movies at all. So there's two possible reasons why it didn't suggest it. One, maybe O3 mini doesn't support parallel tool calling. That's what this is called, is parallel tool calling. Or two, it just didn't think it needed to look up the movies, right? It just, in its thought process, didn't think of it. So I'd have to look into the documentation, figure out like, what is it? Like, can we just not do parallel tool calling at all with O3 mini? Or do I need to like help out O3 mini more and give it more prompts and ideas of how to do this? All right, I see some question here. With parallel, okay, so with parallel function calling, right? So in this case, we're sending all the tools, all the possible function definitions we're sending to the LM. And then we're using a for loop here to iterate through all the possible tool calls. So let me go back to GPT-4o, where we get the multiple responses, right? So we're using a for loop to go through. So we get back all of the suggestions at once. Now, the question is, how are you going to call these functions? So you could call these functions in parallel, right? So you could call them in sequence or in parallel, right? If you wanted to call them at the same time, you could use, like, I would probably use asyncio.task group to call the functions in parallel, right? See how I don't think it's going to do that, but right here we don't even, I didn't even have the ones in here, but okay. Okay, nice. Okay, here we go. Great. Okay. So if I was going to call them in parallel, which is a nice practice, so you can get the responses quickly, right? You make this async IO task group and you go through the response and get the function name, get the arguments, and then create a task. And then we need to wait for that task group to be done. And then it would be, okay, so then we get back the responses, and then we'd actually want to get back the results from that and then decide how to send it. So this is basically pseudocode with Copilot, but yeah, but I think that would be the best practice, would be to to call those in parallel with async IO in order to get the best performance on your server, right? Assuming that these are both, a lot of times they're going to be like API lookups, right? So you might as well send those off in parallel. Okay, let's see if I can answer other ones. How to handle function callings that overlap. So the LM should first call the available dates function before the booking function. Yeah, that's a good question. I don't know. I'd want to look into see how the different agents frameworks do this, right? So there's like, we have all these agents frameworks that wrap on top of this stuff, right? Because you could either like have it be two separate calls, like first, I think I'd first just do the available dates, right? And you could tell the LLM, like, I mean, you could either always pass all of the tools to the LLM and just have it figure out which one is relevant for the current query, or you could just like split it up and say like, okay, first you've got the available dates. Okay, once you get that back, then you give it a new tool. And a lot of times the agent frameworks like AutoGen, they'll use some sort of orchestrator and planner, and that planner would be in charge of deciding like when it's going to call each of the ones that has certain tools. So I think you could try to put all of those tools, always give the LM all the tools, and make it clear through your prompts and descriptions and all that, and even your examples, like when it should call particular tools. But you can also totally split these up over multiple calls if you know that you always need to get the available dates first before you can ever possibly book, right? So I would say it's up to you you to figure out what flow makes sense there. All right. Okay. So these are great questions. Let's keep going just to make sure we can see more stuff. And I have some examples that might help answer some of the questions here. So support for function calling, right? We're just talking about, how this varies across LLMs, right? So OpenAI was the first LLM provider to support function calling, but it is formally supported in many other models as well, right? So OpenAI.com, all the GPT models plus O3 Mini support it. And then for GitHub models, I manually made this list of all the ones that support it. So I actually ran these examples on every single GitHub model to see which ones would work. And so these are the ones that I came up with that were able to run the function calling examples. The other ones had errors where they didn't understand like what tools were and stuff like that. So as you can see, there's quite a few different models you can play with to see what sort of responses they give for function calling. Azure AI has all those same models, and it also has more. And then Olama, you can search in their model catalog to see which ones locally work with tools. When I'm doing it with Olama, I always use Llama 3.18b. That's worked the best for me for function calling, but there are other options as well. Okay, so let's talk about a few function calling scenarios. The common uses of function calling, right? So RAG is a common use of function calling to help you get more structured retrieval. I just saw there was a comment about RAG in the chat. And then agents and agentic flows, right? Having an agent have a tool. And it's hard to say what exactly an agent is, but I think a lot of the definitions of agents have tools, right? Because a tool allows an agent to do something more structured, right? Without a tool, an agent can just respond with text. And there's only so much you can do with responding with text, right? But as soon as you give them function calling, well, now the agent can respond with with suggestions of, oh, you should go do this, and then you should go do that, right? So, very common to use function calling with agentic flows. Now, fortunately, we have a whole hackathon coming up in April where we're going to have 30 live streams about how to build agents. So if you are interested in agents, please do sign up for this hackathon and submit a hack, but also just come to all the live streams where we're going to talk all about agents. So we're not going to talk about it today since we are going to be talking about it so much for the hackathon. All right, so let's look at some RAG scenarios here. So I've got this demo that you can also check out. All right, so this is RAG on a Postgres database, right? And so here, what we have is that if the user asks a question like, do you sell climbing gear cheaper than $30? We first have a query rewriting step that's going to use the LLM with function calling to suggest to call this search database function, or at least suggest this search database function with a suggested search query, plus any suggested SQL operators that it should apply to the SQL query as well, right? So in this case, climbing gear cheaper than $30, it suggests hey, you should use the less than operator with the value 30, right? So I go and click this, right? And all the options it gives to me are under 30. So this is a really nice use of function calling, because if we just asked an LLM to give us stuff under 30, LLMs aren't that good at math, and maybe it's been given a bunch of options that aren't less than 30. So we really want to filter out the rows before we get all the results, right? So you can see this is what came back as the filter, and then all the responses that we get back from the SQL query are less than $30. Let me show so here we can see the system message for this. Let me actually open up the code for this to show you what the code looks like. Back in. Okay. We want the query rewriter. Okay. So here's our function definition, right? I called it search database, even though that doesn't even correspond to anything in my code, but it doesn't always have to correspond, right? I said there's a search query. There's also an optional price filter where you can give it a comparison operator. There's also optional brand filter. And I say the only one that's required, the only parameter that's required is search query. So that's the actual definition. And then, when I'm going through the results, I just grab out the information I need and then use that in order to build a SQL query. All of this code is available. It's all open source. So you can use this front end, you can use the back end, you can use whatever you want. All right, so we get back the response. So one thing I want to show here is that in this conversation, in this request here to get the response, I start off with the system message that describes like, oh, you have access to a database with a table. And, here's the columns in it. And then I provide a bunch of few shot examples. So remember I was talking about in order to improve the function calling results, especially with small local models, you can provide few shot examples. So these are actually examples. So here I have an example of a user asking this question and an assistant saying, oh, you should call this function, right? And then I have another example here, like here's the assistant the user says, are there shoes less than 50? So I give this example here. And then the tool call results. So if you need to, if you need it, you can do few shot examples. And the only reason I added these was because I wanted this repo to work with Ollama local models. And I didn't get good results until I added these few shot examples. So hopefully you don't need to in terms of improving, our responses, right? We always want to start with, prompt engineering, because that's, we just have to change, a few tokens in our system prompt and maybe we get better results. Then if need to, we can do few shot examples, but that does add tokens to our, to our request, which, increases cost, increases latency. So we only do it if we need to. So there we go. And so we use that. So you might be looking like, oh, why didn't I just have it generate the whole SQL query? I don't like having LLMs generate entire SQL statements and then running them on my database because I don't trust it. That is an option, and that's called NL to SQL, when people take natural language and turn it straight to SQL. That gives me the heebie-jeebies. Like, if you're going to do that, you need to be very careful. You need to sanitize the SQL. You need to check for all sorts of things. What I do instead is that I take those queries, right? So these are the filters that I got back from the call. And then I check to make sure they're valid filters. And then I just manually construct a where clause. And I, tack that where clause onto the query that I make later, right? So here's our filter clause, and it gets tackled on. Where does it get put on? There we go. Filter clause where, line 50. Okay. Oh, here. Yeah. So then I just add it to the query. So I want a high degree of control over, over this SQL. Especially this is designed to be like a user-facing RAG. So yeah, but you could ask an LLM to generate the SQL. You just need to be really, really careful about what sort of SQL you're executing. Obviously, you don't want to execute anything that can do write operations to your database, or hopefully you don't want to. So you can check to make sure you're only doing a select statement and, all that sort of stuff. Okay. All right. So we looked at that example. You could also, more examples from RAG, we could use function calling to search multiple sources. If you could look at an AI search index or a Postgres database or a GitHub issue tracker, you could give all those as possible functions to the LLM, and then it could just pick based on the user query what it thinks the best search is. Another example for RAG, or actually any chat app, is human escalation. So you could say, hey, if the human looks like they're like really unhappy, then maybe we should call in some another human to help them out, right? So you can optionally have it call this human escalation function if it detects a high degree of like negative feelings. And we have a PR that shows how to do that for a RAG repo. So these are just some ideas about how you might use function calling for RAG. There's many, many ways that you might want to use it. You could do more planning with it. You could do reflection with it. Lots of different options. Okay, So I do need to move on to structured outputs now because we have 20 minutes left, and structured outputs are also really exciting. So let's talk about structured outputs now. So this is a newer feature, and it is a feature to ensure that your model always generates responses that adhere to a JSON schema. So it's very similar to function calling, and in fact, many people switched from function calling to structured outputs when it came out for the same use cases. But it does also have a different feel for it. I think you'll see from the examples, what you might use structured outputs for. So here's an example of a JSON schema. You can tell it looks really similar to the function definition as well, because they're both basically using JSON schema. So that should look somewhat familiar. But in this case, we do give it a name. We say, okay, this is the calendar event schema, and then we describe it. Now, the cool thing in Python, we can describe all of these schemas using Pydantic. And this is what's really nice about using structured outputs. Pydantic is a great library for doing data validation. It's often used by Fast API. If you've used Fast API, very popular model. It's a great way to describe your data and then just be able to make sure that your data is always adhering to that scheme, right? So for that, this gross JSON here, we could just describe it as, calendar event, and extends the Pydantic base model. It has a name, which is a string, a date, which is a string, and participants, which is a list of strings. So this is called a Python type annotation. When you see the variable name, colon, the type, that's called a type annotation. So in Python, type annotations are optional because Python is a loosely typed language. So type annotations are optional, but many people have started using types throughout their code, especially when describing, classes and data models and that sort of thing. It's really helpful to have types for it because then you can ensure that you're always sticking to those types. We also often use type annotations for function signatures to make sure we're passing the right thing into functions. So these are using type annotations in order to describe what type this is. So that's a basic Pydantic class here. Now, the cool thing is we can directly pass a Pydantic model to the OpenAI SDK, and it will turn it into that JSON schema behind the scenes. All right, so going back, let's go to structured outputs. Okay, so here's our Pydantic model, the calendar event model, and so first we actually use a slightly different method here. So it's client.beta.check.completions.parse. And we give it the response format of calendar event. So we say, hey, your response must adhere to this schema. Let's run this here. All right. And we look at the message that came back, and either that message is going to have a refusal parameter, a refusal attribute. And if we see refusal, if refusal is not none, that means it was not able to give back a response that adhered to this schema. So we have a very clear way of knowing that it didn't adhere to a schema. So this is super useful because one of the issues with function calling is that a lot of times you'd get a response that didn't adhere to the schema, and you didn't have a way of knowing that for sure. So you just had to code really defensively. But with this example here, we get back that response, and we're just going to know that, okay, either it did generate something that adhered to the schema, which is this, or it didn't, and it gave us a refusal, which will usually have, I think it usually has a reason or response. Okay, so let's see. I'm just going to rerun it. So, okay, so there we go. We got it. Let me make that bigger. Okay, so we got back the response, right? Calendar event. Calendar event has a name, a date, and participants, which is a list of strings. Beautiful. So as we saw, this is how we handle the response. Always check for refusal. And if not, you can get the Pydantic instance out of that parsed attribute. And that was the full code that we just ran. All right, so now let's get a little bit fancier, all right, and see what other stuff we can do with these Pydantic models. So if we look at this one, this calendar event is similar, except I have string equals field. This is coming from Pydantic. and field has a description. So if you find you need to give more information to the LLM about how to format a particular, a particular field, then you can use this field thing here and give it a description. So let me go ahead and run this one. And so this time we should get a date in this format. And here we've got a slightly different one. It says 1st of April. We also told it what the current year was so that it could come up with an accurate year. Otherwise, LLMs usually think it's 2024. They think that's when they were trained. Oh, can I explain the 3 dots? Yeah, that's a good question. I'm going to have Copilot explain them. Let's see if Copilot will explain them. I think actually that's what let's see, explain. I just said explain 3 dots. I should really give it the fuller explanation here. Okay, so the ellipsis, shorthand in Pydantic that marks the field as required. Is it really? Okay, I'm going to ask again. What does the ellipsis operator mean in Python? Okay. Pydantic seems to be the main one that uses it. All right, it says once again, okay. All right. Oh yeah, so this is when I'm used to using it. You can use it slicing. All right. So I guess the ellipsis operator you can use in various ways. So I guess Pydantic has decided to use it in a certain way. Interesting. Okay, so it seems like it's kind of a generic operator in Python that's been used by different libraries in order to mean different things. Interesting. I need to research that more because, there's only a few cases where I've seen the ellipsis operator, and I think I need to look more on the Python documentation. It's a really good question. All right, so we got back the response, and we can see that the date is indeed in exactly the form that I requested. Okay, great. So that worked. Now let's see, how can we restrict the string values of properties? And we're going to use something from Python called the enum in order to do that. So let's open up the enum example here. Okay, we have the enum. And here, what we can see is, so we bring in enum from the Python standard library, and then we say, okay, we're going to make this enum, and this time it's a string type enum. You could also have like integer type enums. And here I say, okay, these are all the possible values of this enum. So every enum has, I feel like now normally I don't say it aloud. Now I'm thinking it's enum. But it's like enumeration, right? We're enumerating the possibilities. Anyway, enum, what should it be? So here's the variable name for it. And then this is the actual string value, right? So that's our enum. And now for date, I'm going to just say day of week. It has to be one of those possible values, right? And this time we're back to saying just Friday. So let's try this one now and see what kind of response we get. I see there's a question. Should I convert all my data classes to Pydantic? That's a really good question. Data classes are also pretty nice. So data classes are built into Python. That's a part of Python. And I still use data classes quite a bit as well. There's a lot of good things you can do with them. And I think maybe also with Pydantic, do you have the option to use data classes like the base type? Yeah, so you can also use, I haven't tried this with, with structured outputs, but with Pydantic, you can do, let's look at this one, right? Pydantic data classes, import data class. So they kind of have a wrapper of data classes. So this might be a more gradual thing. I think though, you're not going to get as much functionality with data classes as you get with Pydantic. So I would check out this to see, what would make sense. All right, let's see if it got a response. All right, so now we got a response, and you can see that it suggested the enum, which has this variable name and this value, right? So that's great. Now we can restrict things to only particular values. And then finally, we can nest the data models, right? So this is really helpful. You can get really, really, hierarchical nested data. So here we have a calendar event, and the participants is going to be a list of participants where each one has a name and a job title. So this time it has Alice the carpenter and Bob the plumber. All right, so let's try this out here. Okay, just running that, looking again at this code here, right? So these are both Pydantic models. And this one is referring back to this model here. And that's how you can achieve really rich nesting. And I know there's a question about combining structured outputs and function calling. That is coming up right after this. Right there. All right, let's see. While that's running, I'll also just try running this locally. Let's see. I think that the latest version of Ollama does support structured outputs on all the models, but I haven't actually tried it. Oh, I just need to update that. I didn't update my environment. Let's see. Okay. All right, now I'm going to try running that one here too. See how it works with Ollama. I think Ollama announced in January the support for structured outputs. Now, when Ollama introduced structured outputs, Ollama did it in a way that they added it to every model, right? So there's two ways of adding this, kind of function calling and structured outputs. Like one way is that it's actually part of the training, right? Like there's actually kind of like a fine-tuning training process that trains an LLM to understand how to adhere to JSON schema, how to respond to function calling requests, right? And that's what the OpenAI models did. The other way is you like adding on a something on top of all the models that says, hey, the user wants this JSON schema. Here's what the JSON schema looks like. Respond with it, and then and we'll make sure that it validates. So that's the approach that Ollama took in order to add structured outputs to all of the models. But that probably means that it's going to work better for some than for others. Okay, and this is working with Ollama locally. So yeah, it does work also with the Ollama local models. Okay. The one thing with GitHub models is that it's not always super speedy since we're sharing resources. So it's just easier just to restart the call. All right, so there we go. We got a list of participants. Okay, great. All right, so that gives you a feel for many things you can do with Pydantic models in order to get really nicely structured outputs. Now, there's a question about how do we combine function calling with structured outputs. So yes, you can combine them with at least with the OpenAI models, right? So that's this example here. So we've defined our function using a Pydantic-based model. And I said this is the function name, and this is the argument that it takes. And we use this function from the OpenAI package to turn it into a tool, and we pass it in. So let me go ahead and run this one. So why would we do this? So there's two reasons. One is that we can use Pydantic to define our functions, which is nice. It's very structured. It looks much prettier than that gross JSON that we had before. Two, the other reason is that behind the scenes, when we do this, it is passing to the API this strict true parameter, which means that it's actually going to check to make sure that the response adheres to the schema. So that's really, really nice. Because as I was saying, with normal function calling, you can get back responses that have hallucinations that don't adhere to the schema. So you have to code really defensively to make sure that it actually gave you function names that exist, that all the arguments are what you expected, that they're the right data types, right? Like it's kind of exhausting to do all that check. So this is what's really nice is the fact that it's actually passing strict true behind the scenes. Now, there's one big gotcha here is that it is not supported with parallel tool calling. So if you wanted to give it multiple function definitions, it just wouldn't work. And that seems like a big limitation to me. So hopefully that will change in the future as they come up with new models. In this case, and so there was a question about exception handling. So what I would do is, I didn't do that's a good question, actually, because we don't have the refusal. Do we have refusal in this one? I don't think we get a refusal in this one because this time we're using chat.completions.create. We're not using the .parse function. So I think we just would want to make sure that, that there is a tool calls, right? So I don't think you'd have an exception per se. You would just want to make sure that there is a tool call. Otherwise, you would just print out. I don't think you get a refusal. I think you would just get the, just the content of the message. All right. Okay. So talking about support for structured outputs, it's in a bunch of the OpenAI models, and for Llama, it's on all the models. I couldn't find any other, GitHub models that supported structured outputs because it's saying like typically that's actually baked into the model, except that Llama found a way to add it to all of them. So we'll see as time goes on if more models add support for structured outputs. Let's look at a few scenarios in the last 5 minutes that we have left, right? So why do people use structured outputs? Well, one, it's an alternative to function calling, right? So many cases where you use function calling, you might want to use structured outputs or that combo that we just saw that sends strict true. NT extraction is a big one, and I'm going to show a bunch of examples of that. Some people use it for OCR. We talked about that in the vision stream, when you should use it, when you should maybe not use it, and it's much better to use an OCR tool. But we're going to look at entity extraction today, which is a really good use for it. And I've got a bunch of examples for it, right? So we'll post this repo in the chat. This is another repo that has a bunch of examples of different pieces of content that we could send to an LM and get back a response using structured output. So let me go ahead and open up that one and go through some of the examples, right? So let's see here. All right. So we have let's say we have a GitHub issue, right? And we want to, build a little automation, triaging our issues, right? So we could fetch that issue and then get back a structured description of that issue, right? Like maybe with the operating system and the issue type. I really need this to help me manage my GitHub issues. I really should start automating the triaging of them more, right? So then we get back issue with a title, description, a type, and an operating system, right? Okay, so that's pretty cool. We can do the same thing in the repo. Let's look at a web page, right? Let's say we want to extract information from a web page. So here I'm extracting from my blog, and I pull out title and summary, and I also tell it to generate tags. So this is what's interesting about using an LLM for entity extraction, is that you can both extract things that are there, but at the same time, you can have it generate things, right? So I'm telling it to generate a summary, right? So it's extracting the title, but it's generating the summary and it's suggesting possible tags, right? So you remember when we're using LLMs, they are generative. So really everything's generative. And you can kind of, use that when you're doing entity extraction to get nice results like this. Let's say we have an image. So here we've got an image of a graph here, right? That's the graph. And we wanted to describe that image. Here's the graph. Okay, so we say, all right, here's the graph. You're going to describe it. And we open up that image. So here's an example of combining structured outputs with vision models, right? So we can use both those things together. So we're passing in the image as a base64 URL here, and we're telling it, okay, you should describe this image using this structured output model here, right? So it's going to give us a title, description, axes, and legend. And so this is cool because it means anything that you can turn into an image, you could then send to the model and use structured outputs in order to extract information from it. Let's go do it again, go faster. I have a similar example here with extracting information from the table, right? And this is where I'm using nested models in order to get really structured information. Once again, as we talked about in the vision stream, we do want to be careful about relying too much on these models to do OCR for us. Like I was able to get good results when I did a single page, but if I sent multiple pages, then the results really deteriorated. So if you are going to do something like this, you really want to do a good quality evaluation to see that it is working well. Okay, so you can go through all of those in your own time. They should all work with GitHub models as well so that you can run them in code spaces. We are at 10:30 now. So you can see all the examples also in the slides. Cool. Okay. All right. So let me share the next steps. We have one more upcoming string this Thursday. We're going to be talking about quality and safety and evaluation. So that should be really interesting. I'll be joined by a colleague, April, who's going to be talking about quality and safety as well. I have office hours after it on Thursdays in Discord. It's like I think it's at 1 p.m. Pacific Standard Time. And I know there's a question about, whether they'll continue. I'm going to continue doing those office hours actually indefinitely. We'll see. They've been really great, really helpful. I like getting the questions and and I always learn something from them too. So I will have office hours indefinitely. Once again, make sure to sign up for the AI Agents Hackathon. If you haven't signed up for that yet, there's going to be tons of streams and 50,000 worth of prizes. Pretty great. And then if you want to get more Python AI resources, you can sign up for the newsletter and get a bunch of links from this URL here. Yeah, as long as you all just keep bringing great questions to office hours, then we will keep having them. And I know Gwen has also been running Spanish office hours on Mondays and says she's also gotten great questions. So yeah, just keep coming, keep having great questions. I know that there was, as always, there's lots of questions in the chat that we, didn't get to. So please do either bring them to office hours. You can also post them on the YouTube recording for this video, because I do try to check that a week after to see if there's any questions. Or you could also post it in the GitHub repo in the discussions there. So many places you could post any additional questions that we didn't get to. But hopefully this gives you an idea for function calling and structured outputs, gives you more tools in your toolbox, and also maybe will help you understand more when you're using something like AutoGen, these different agents frameworks, kind of see behind the scenes, get the idea for oh, okay, it's using this and this feature of the model. All right, thank you, everyone. See you Thursday.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.